Well, now we're going to do exercise 3 that says determine the minimum and maximum of quadratic expressions. Okay, so this is exercise 3 says determine whether each of the following expressions have a maximum or a minimum, and then find the value. Let me recall that quadratic expressions are of the form ax squared plus bx plus c. Okay, this type of expressions has either one minimum or one maximum. Okay, now we said we can solve this by complete the square, and then it's going to be the form a open brackets x minus p raised to the power of 2 plus q. These forms helps us determine the maximum or the minimum of the quadratic expression, where a here, the leading coefficient, okay, has two forms. Okay, if a here is greater than 0, if it is greater than 0, or in other words positive, if it is positive, then it has a minimum. I just want to abbreviate as min. Okay, and then if this the a here has a value which is lesser than 0, okay, lesser than 0 means negative. Okay, then this means the quadratic expression has a maximum. I say it's max. Okay, now the p and q here determines what you call the turning point. Okay, so the turning point is p and q. Okay, this tells us the coordinates of the point, which is either a maximum or a minimum. Okay, now let's dive into the exercises. Okay, now question 1 is given by negative 9x squared. Over here we will say this is the leading coefficient here is negative, so negative 9. Then we understand that this expression here is a maximum. Okay, because it has a maximum, value. Now, how can we get that maximum value? Because we said it must be of this form. This form occurs when we completed the square of a quadratic expression here. Now over here, understand that b is just 0, so it's like 0x, and then c is also 0. So if I need to complete the square, I'll use my c value. Okay, b over 2 to the power of 2. So now here the c value is just going to be 0 squared, which is 0. Okay, because b is 0, 0 divided by 2 is going to be 0, 0 to the power of 2 is 0. And yeah, that's what we can do. And then if I want to complete the square, I'll say negative 9 open bracket x minus 0 to the power of 2, okay, plus 0. Now the point that will determine the maximum is the point 0, 0. Okay, the point 0, 0. Now this is the point 0, 0, where is the minimum. But if I need to say the minimum value, then actually the maximum value then is just 0. And I look at this one, this here determine the maximum values. I'll say here this is the maximum. Okay, so the maximum is the max or min is the q value here. So the value outside the brackets. Okay, so this is 0. So see here maximum, it has a maximum, and the maximum value is just 0. Now let's do question B. B is 9x squared. Okay, so when we look at 9 is, this 9 here is positive, is greater than 0. Okay, therefore it has a minimum value. Okay, because it's greater than 0, it means it has a minimum. And now those are special cases. I didn't really have to do all these calculations here, but I was just showing. But those are special cases when B and C are 0, we understand that the minimum and maximum will occur only at 0. Okay, so here the minimum value is just 0. After doing these calculations, might be 0. Okay, now see, we have like -2 minus x to the power of 2, like that. You know, when the power is 2, it means regardless of the sign of what is in the base, it's still gonna be positive, okay? Or for what is within the bracket, the base within the bracket, we still gonna be positive. So this is the same thing as to say -x minus 2 to the power of 2. The two here are equivalent, okay? Now the fact that we see a negative sign there, we understand it's a -1 there. This is negative, then we say it has a maximum. Now we need to find that maximum value. Over here, we can complete, it's like +0 also, okay? So, of course, I will answer a question which were not asked. I'll say the turning point here, the turning point is -2, 0. I'll look at this -2 here, 0, because we did say that the turning point was PQ, okay? Is not -2 actually, sorry, +2, +2, 0. But the maximum value here, the max, that's just the max here is 0 because it is that value here outside the bracket. Okay, the maximum is 0. Now, question D. We have just x squared plus 1. Okay, again, this x squared here can be written like this. We can write it as x minus 0 to the power of 2 plus 1. Okay, which is the form that we're talking about. This is the form, okay, with 1 out there, okay, and then the fact that this 1 is positive, we say that this has a minimum, and then the minimum value is just 1, this one here, okay. This is minimum because it is greater than 0. It's greater than 0, and then it's a minimum, and that minimum value is this value here, 1. Okay, and then E. E says 4 open bracket 3x plus 9 to the power of 2. Okay. Always keep in mind that we want this form ax minus b plus q. Okay. So in this case, we can see that this is positive. Okay. Now, and then we don't have any number outside there, so we can complete it by 0 there. So this means that because this is greater than 0, it has a minimum. Okay. Okay. I'll say it has a minimum. A min because this is greater than 0, and then the minimum value here is just 0. F. F is given by -2 open bracket x minus 3 to the power of 2 plus 9. Now, in this case, because this is is lesser than 0, this is lesser than 0. Okay, we'll say this has a maximum, and then the maximum value is what? Is 9. This 9 here outside the bracket. Okay, F G we have like 2 open bracket negative x minus 1 to the power of 2 minus excuse me, minus 3. So this is a positive, so it's greater than 0. Then we'll say because it's greater than 0, it means it's minimum, and then the minimum value is negative 3. So that was question 1. Well, we have question 2 and question 3. We do them. The question says that determine the maximum values of this expression by completing the square. Why? The question says determine the maximum value. Yes, because this expression has a maximum value. Why? You look at the leading coefficients here, it's negative. Okay. And question 3, they say determine the minimum value. Obviously, because this has a minimum value, because the leading coefficient 2 is greater than 0. Now let's start with question 2. Okay. I need to determine the maximum. Okay. What I'm gonna do by completing the square, okay, I will get rid of the negative sign there, the coefficient of x squared. So I'll write here minus 1 in the bracket like that. And then within the brackets, what we have now, x squared minus 8x plus 12. Okay. We do know that c will be equal to b over 2 to the power of 2. Okay. Now I am going to look at the b value here is negative 8. Now this will be what? Negative 8 over 2 raised to the power of 2, which makes 4 squared, which is 16. Now that we have that value, I need to complete within the bracket here. That makes negative 1 x squared minus 8x plus, okay, that's plus 12. But then I need to write 16 over here. So what can I do? I am going to say plus 4 squared. Okay, knowing that this is 16. And but with the negative sign outside, the negative 1, they understand that makes negative x squared plus 8x minus 16. But if you look at the initial problem, it was negative 12. It has a negative 12 here. I'm trying to look at this, comparing this and that. So this can be negative 12 then if we plus 4 there, okay? Because this will be then negative 12. You see? So I'll plus 4 there, and then I must plus 4 over there. So I can just erase this part. And then I can just put minus. I don't need to put negative 1. And then I'll write x, and then I'll use the sign of the middle term, and then 4, the power of 2 is there, plus 4. Now we can say we completed the square. I say that the quadratic equation is of the form ax squared plus bx plus c, as we said. And then we said we can complete the square, which means it's like the form a x minus p to the power of 2 plus q, where pq is a turning point, pq is the turning point, the TP, and the maximum is just equal to q. Okay, so in this case, the maximum or the minimum, okay, I can say min or max is equal to q. Now, in this case, we can say that the maximum is 4. Okay, the maximum just 4. Question 3 says determine the minimum of this expression. Now we can see that it has a 2 there, so we can factorize. We can take 2 for common factor, and then this will be x squared plus 3x. Now what can I do in this case? The b value is just 3. So we say C is equal to B over 2 raised to the power of 2. That makes what? 9 over, excuse me, 3 over 2 to the power of 2 is 9 quarters. Okay. We have 9 quarters over there. Then we can complete this value over here. So this will be 2x squared plus 3x plus right here 9 over 4. Right there 9 over 4, close brackets. But now, note if I write 9 over 4 there, it's not just 9 over 4, because if you times the whole equation by 2, this will become 2x squared plus 6x plus 9 over 2. Okay, now we're going to say to ourselves, if we have like 9 over 2 plus what will make 0, because there initially the C value here was 0. Okay, you know, it's I don't really need to do that. I say just minus 9 over 2, because 9 over 2 minus 9 over 2 equal to 0. So meaning it means here I'll minus 9 over 2. Then we can just erase this. And then this will be 2 open brackets x, okay, plus 9 over 4 is just 3 over 2 to the power of 2. Okay, so 3 over 2 or to the power of 2 minus 9 over 2. Therefore, the maximum, in this case, the minimum, will be just negative 9 over 2. Okay? Well, we have another question here. The question says, show that x squared plus x plus 1 is always positive for all real values of x. Okay? Now, we can do that by completing the square, okay? Over here, we know that the values, the coefficients are like 1, B is 1, and then C is 1. As I was saying, all quadratic expression is of the form ax squared plus bx plus c. Okay, so A is 1, B is 1, C is 1. Now, the completing the square, it means we must write this in the form A open brackets x minus b to the power of 2 plus q. Okay, and then we do this c equal to b over 2 to the power of 2. Now, in this case, b is 1, okay? So it's going to be 1 over 2 to the power of 2, which is a quarter. Then I can write here x squared plus x. Instead of me writing 1, I am going to write a quarter, okay? Plus a quarter. But initially, it was 1 here. But now we have a quarter. If I need 1, what can I do? I know that if I have a quarter to get 1, I can just add 3 quarters. You know, because 1 plus 3 makes 4, it's going to be 4 over 4, it's 1. Then we can only take the basis, okay? So x squared plus x, a quarter is just a half to the power of 2 as we did it here, okay? Plus 3 quarters. Now we're going to take this basis x and then a half. So this will be to the power of 2, then it's going to be like x plus a half, okay? Plus 3 quarters. Now, it is important to note that all square numbers are positive. So this is a squared is positive or 0, okay? And then this part also is also positive. This is also this is a positive. Now we have the situation where we have like a positive or 0 plus a positive will always be positive, okay? So even if all this was 0, 0 plus positive number plus 3/4 will be positive. And if it's a positive also, more than 0 plus positive is going to be positive. So we can say, therefore, x squared plus x plus 1 is always positive, strictly positive. Okay. Well, now we're going to do exercise 5, exercise 3, question 5. The question says that a farmer has 100 meters of wire fencing from which to build a rectangular chicken run. He intends using 2 adjacent walls for 2 sides of the rectangular enclosure. Now, question A says, determine a formula for the enclosed area in terms of x. Okay. And then B, determine the dimension which will give a maximum enclosed area. All right. Meaning because the farmer has like 100 meters of wire fencing, and then he's gonna use that to he stands using 2 adjacent holes for 2 sides of the rectangular. So this hole were there already. So meaning the 100 meters are this and that. So x plus y makes 100. So we can notice that here, x plus y equal 100 meters. Okay. Then this means y can be 100 minus x meters. Okay. So if this is x, and that will be 100 minus x. Okay, you can check it. X plus 100 minus x makes 100. If you do x plus 100 minus x, okay, we have like x and x simplified, and then the answer is just 100. You see? Now, the question says determine the formula for the enclosed area in terms of x. So the area is a rectangular, is a rectangle, as the question says. It's a rectangular area. So the area of the rectangle is given by length times breadth, okay? And so we can just say the area will be x times 100 minus x, okay? Which is 100x minus x squared, or area will be equal to negative x squared plus 100x. So that's the area in terms of x. I can even write like to indicate that it is in terms of x. I can also write this way, a of x. Now B, that was question A. Now B, the question said determine the dimensions which will give a maximum enclosed area. So to do that, we can do that by completing the square, okay? We're going to look at when they say the maximum, and then is this true because the leading coefficient here is negative. So we can take negative out for the common factor, -1. And then this will be like x minus 100, x squared minus 100x. Okay. Now we note that here B, okay, in the quadratic equations is just -100. Now we can say, we know that to complete the square, we do C equal to B over 2 to the power of 2. So we will do -100 over 2 to the power of 2, which is 50 squared, because the power is 2, the negative within the bracket, the negative of the base within the bracket will disappear, and then this will make this much 2,500. Okay. So I am going to write here negative x squared minus 100x. Okay. Then I will add within the brackets here, I will add plus 50 squared. Okay, I prefer to write it 50 squared. I know it's 2,500, but I write 50 squared there. Now, if I do that, understand that, okay, this is 2,500. Understand that initially it was negative x squared minus 100x, but now it becomes, so if I times with a negative, right? If I times a negative here, now it becomes like, I add also another negative 2,500 here, because when I times here, it was only negative x squared plus 100x, but now it has another negative 2,500 there. So to cancel it, we can just add 2,500 here, because I know this, all this will make 0. So I'll do the same there also, negative, no, I mean plus 2,500. And then we know that this is the value, okay? This is basically the value that makes the maximum. So the maximum here, okay, let's just complete this. This is gonna be like negative x. It's gonna be like negative, I'll write here x, and then minus 50, like this to the power of 2, plus 2,500. And then as I was saying, the maximum value will be this one, 2,500 meters squared. So therefore, the max will be 2,500 meters squared, the maximum area. Thank you.